Today we are going to study about similar triangle. Write down the topic name, similar triangle. Okay. Now, in previous class, we studied about congruent triangles. Okay. First, what are the differences between congruent geometrical figure and similar geometrical figures? Okay. Basic ideas about congruent figures. Those geometrical figures which are equal in shape and size both are said to be congruent figures. Any two geometrical figures are said to be congruent figures if they are equal in shape and size both. Okay. For example, you can take two line segments AB and CD of same measurement 5 centimeter. Okay. Because both are of the same shape line segment and both have the same measurement 5 centimeter. So it satisfies the definition of congruent figures. Therefore, you can say AB and CD are congruent to each other. Means if you put AB on CD such that point A must coincide with point C and point B must coincide with point D. Okay? Means both are overlapped such that they became as a single line segment. Okay? So these are the examples of congruent figures. If you can take another examples of congruent figures, two circles are said to be congruent if they have equal radii. Okay? Now like this you can take another two triangles of same shape. Suppose I am taking two triangles of same shape, equilateral triangle. Both are equilateral triangles. Okay? You know in equilateral triangle each angle is 90 degree. So if you put in equilateral triangle each angle is 60 degree. So if you put ABC to other triangle, equilateral triangle DEF, such that point A coincide with D, point B coincide with point E, and point C coincide with point F. Both are overlapped to each other such that both figures are looking of the same type of equilateral triangle, same single figures. Means two triangles are said to be congruent if it satisfies the following condition. Corresponding angles are equal, and second, corresponding sides are also equal. Okay. Now, in terms of similar triangles, we will study about the similar geometrical figures. Those geometrical figures are said to be similar when they are equal in in shape but not necessarily equal in size. Okay? Suppose we are taking two circles. One is smaller, another is bigger. Both are of same shape circle and both have different radii. So size are not same. So you can say both circles are similar circles. Now in terms of triangle, we are taking two triangles of same shape equilateral triangle. One is ABC, another is DEF, in which triangle ABC less than triangle DEF. But both are of same type of triangles, both are equilateral triangles. Okay. Now in this case you can say the shape of both triangles are equal, means equilateral triangles, but sizes are different. Sizes means pair of corresponding sides of two triangles are proportional. Okay, are in the same ratio. So two triangles are said to be similar if first corresponding angles are equal, and second, corresponding sides are proportional. Corresponding sides are proportional. Okay. In case of triangle ABC, and triangle DEF, since both triangles are equilateral triangles, so in each triangles, every angle of each triangle is 60 degrees. Okay? 60 degrees. Means angle A is equal to angle B, angle B is equal to angle E, or angle C is equal to angle A. And second, corresponding sides are in the same ratio. Okay? Means AB by DE is equal to BC by DF is equal to CA by AB. Corresponding sides are in the same ratio. Then you can say triangle ABC is similar to angle DEF. Okay, means pair of corresponding sides of two triangles are in the same ratio. Means whatever the measurement of all three sides of first triangles and measurement of all three sides of second triangles are given. Now to take the ratio of AB by D, BC by EF and CA by FD. Okay, means all ratios of pair of corresponding side of two equilateral triangles should be same. Then you can say triangle ABC is similar to triangle DC. Okay? In terms of polygon of any sides are said to be similar if their corresponding angles are equal, and second, pair of each ratio of pair of each corresponding sides should be proportional, means should be in the same ratio. Okay, so these are the basic differences between congruent figures and similar figures. Okay, so in this topic we will study about similar triangles, in which case two triangles what are the criteria for being two similar triangles. Okay, like what are the criteria for being two congruent triangles? You know, there are four congruency relations of being a congruent triangles. Here there are three similarity criteria for being a similar triangle. Okay, we will discuss each by each in a class. Okay, so these are the differences between congruent figures and similar figures. Now it is clear. So similarity is not for only triangles. Similarity is for any geometrical figures in which if you are taking two geometrical figures, both are in the shape of triangles, both are in the equal shape, like both should be equilateral triangles, both should be isosceles triangles. Okay, and then both conditions must be satisfied. First, corresponding angles must be equal and corresponding sides are proportional. If two things are satisfied, then we can say that the given geometrical figures are similar figures. Okay. Now in this topic, there is a theorem which is known as Thales theorem. This is known as Thales theorem. Or basic proportionality theorem, or basic proportionality theorem is also known as BPT theorem. Since Thales was the Greek mathematicians, who proposed that theorems in the triangles. That's why this theorem is known as Thales theorems, and also it is known as basic proportionality theorems. It is for all triangles. Now, any triangle, the statement of theorem is in any triangle, a line drawn parallel to any one of its sides, then this line divides the remaining two sides in same ratio. It is for any triangles. So I am taking a triangle A, B, C, A, B, C, B, any triangle in which a line DE is parallel to BC. Means line D is parallel to BC. Is drawn, then line segment D divides the remaining two sides AB and AC in the same ratio. That is AD by BB is equal to AE by BC. Like this you can say DB by AD is also equal to EC by AE. Whatever you are taking ratio in side AB, the same ratio should be in other side, remaining side AC of triangle ABC. Now, third condition you can take AD by AB is equal to AE by AC. Now, fourth reverse is AB by AB is equal to AC by AD. Okay. Now fifth, BD. Fifth, AD by BD by BA. BD by BA is equal to C by CA. And sixth, BA by BD is equal to CA by CE. Like this, there are 6 relations between the sides AB and AC of the given triangle ABC. Okay, main things, what you are going to make the relation in the side of AB, then same relation should be in the other remaining side AC of triangle ABC. Okay, so these theorems was given by Singh, who was Greek mathematician. That's why that theorem is known as Thales theorem. Okay, and it is also known as basic proportionality theorem. So it is for any triangle. So if any triangles are line drawn parallel to any side of a triangle, then this line divides the remaining two sides in the same ratio. Okay, here D is drawn parallel to BC. You can draw D parallel to AC also, or you can draw D parallel to AB also. There are three cases of drawing a parallel line to the sides of a triangle. Okay, now sometimes it is asked to state and prove the Thales theorem or BPT theorem. So a statement of this theorem must be learned, and after that you take a particular triangle or make a triangle like a screen triangle because these sides are different, and after that you take a parallel line of any given size. Okay, sometimes figure is made and one parallel is drawn to the side of triangles of the given triangles. Now one relation is given. Now we have to proceed that relation. Okay, so in any case, any type of relations are coming in the triangles where a line is drawn parallel to any sides, then we can prove it on the same procedure which is adopted for every relationship. Okay, so in next class we will discuss